Hi and welcome to Metrics Explained. This is my YouTube summer project in which I'm trying to explain the most frequently used metrics. I will start off by what I perceive the most obvious candidate, which is accuracy. In machine learning, we commonly have some input data, for example, an image of a cat, and feed that to some model to get a prediction. The basic question the metric accuracy is answering is how often, relatively speaking, is that prediction correct? Let's now look a bit deeper. This is what we call a confusion matrix. It is being used for classification problems. In it, we summarize how well a classification model is performing by comparing the actual true data classes against what the model predicted them to be. Let us assume we want to classify images of cats, dogs, and birds and cows. So our images have those four classes, and these are also what our model will try to predict. Let us say we have in total 5 cats, 10 dogs, 3 birds, and 6 cows, or images thereof, of course. Now, our model correctly predicts 4 out of those cats and thinks 1 is a dog. The dogs are mostly predicted correctly, but we have some false predictions for cow and for cat. Our model is also not good at birds, so it only gets 1 of them right. And finally, it's also not good at cows and predicts most of them as dogs. So in a nutshell, the model is great at our furry pets, like cats and dogs, but not great at the rest. To calculate the accuracy, we now look at the main diagonal of the confusion matrix, and we sum that up. We divide the sum by the total number of samples. In our case, this is 14 over 24, approximately 0.58. It's that simple. And accuracy is also widely used, yet accuracy has some drawbacks. One of the most notable ones is most easily explained by this graph. Imagine a situation where we have 100 cats, but all of them get misclassified in an otherwise perfectly working model. The model is thus great at these 3 classes that are not cat, but not good at the remaining 1 cat. We would imagine some kind of a, 3/4 accuracy, because it's correct in 3 out of 4 classes. But that's not what we're getting. In fact, we're getting 30 over 130, so round about 0.23, much less. So the accuracy is strongly dependent on the frequency of the classes and ignores a possible class imbalance. Now, what can we do against this for classification problems? Have a look at my next video in which I will be covering balanced accuracy. Until next time, have fun and stay above the baseline.